All right, so moving on to the loading parts. Here, as you can see on the top, we have 5 types of different loads. As you can see, we have nodal forces. You have also membered end moments rotations. You have uniform loads. And here you have linear loads. Also, you can apply thermal loads. We'll talk about this in soon. For this video only, let's just apply a nodal force in here. To create this, just like the other parts, you click a new one. I'll just call it P equals to 5 kilonewtons. I'll click done. And here you can apply 5 kilonewtons into the bidirectional axis and also moment. Since we're just creating a load, I will apply a -5. And I will select the nodes and this apply, right? As you can see here, it was applied a point load to the node, all right? You can also change, if you change the sign, if you just click here, it will go up yards, okay? And you can also change this to go down yards. And also you can increase the load if you want, -10, for example. And I don't know if you can see here well, let's just click in display and let's enhance the units. So the text, let's put it large. And here, the loads, let's put large. And also the supports, let's put large. Okay, so increase this. So 10 here. You can also create moments. So I'm just going to put 5 kilonewtons per meter. And if you put a negative sign, it's going to change directions. And also if you put a horizontal load in the X direction, let's say 7, it will apply here 7. If you click negative, it will apply to the other side. So this is pretty cool. And you can also define bending moments if you want. For example, I can select the sidebar and I will put the moment, for example, let's just put -3 kilonewton meters. I'm gonna click done, and here I'm gonna put -3 in one side. Click here, and one side you have the nodal bending moment there applied to the support. If you put +3, it's going to change directions, and if you apply to the other side, -3, you're going to apply another one here. So this problem is quite interesting because you can pretty much define every type of nodal forces as you like. And the program is very friendly, as you can see. Let's also apply a uniform load here in this span. I'm going to just, like the other options, create a new uniform load. I will put Q equals to 4 kilonewtons per meter. I'll click done. And on the Y direction, -4, so the load can be towards facing down. I'll click apply. Apply. All right here. Again, if you change the signs, they're going to be applied towards the upper part of the bin. I'm just going to leave it 4. And also, if you apply on the X direction, you will create a distributed load from the top to the bottom of the frame, let's say like 3. You can change that. This is quite interesting. Put 0 here, as you can see. Okay, so you can play around with this like 5, and you can see that the load is actually going to be tilted with the resultant force here. All right. In this situation, we were just talking about 4 and 0 here. But if you want, you can create multiple loads. Let's create another one here. For example, P equals to 2 kilonewtons per meter. I forgot to click in per meter. Okay. And I want to apply this horizontal force in here, just like equals to -2. Actually, it's 2. And then apply. As you can see, this section of the beam is going to be under compression by 2 kilonewtons per meter. Okay, so wow, this is pretty cool. And you can also create linear load. We'll talk about this when we talk about frames. And the thermal loads, I'll talk about this whenever we're talking about frames as well. From now, I'm just going to click save. And let's see the results in the next video.